afternoon and welcome to this webinar organized by Thurne. This webinar is about how to optimize the throughput of the separator. And here's me, the Johan Andersen, and the spokesperson is Cang. And if you have any questions or concerns or something like that, you can reach me or Morten Christoffersen in Denmark. And this, you can follow us on this Facebook, LinkedIn, and YouTube. And let us begin.
Okay, perfect. Thanks. Thank you, Johan. So the topic today is the optimization of the throughput of a separator. So first, where are our separators used? We have different types of application, like sizing, when you have different separations and different fractions that you will have, like for different products like sugar, spices, starch. We also have scalping, when you want to remove the oversized particles from the product. For example, milk, cereals, sugar, coffee. You will also have filtering if you want to remove some particles from a liquid, for example, fruit juices, soybean oil. And we also have another type of application. It's wastewater, when you want to clean the wastewater from all impurities and other things. What are the key factors affecting performance? We listed 4 of them. First, we have the material characteristics. Second, we have the screen opening. Third, we have the blinding. And fourth, we have the types of screen motion. Today, we will focus on the blinding. So I will give you a presentation on the different deblinding solutions we have. And after that, we will show that to you live in our laboratory. So what's blinding? It's the, you see here, a normal screen, so without any product. And over the production time, you will start to see some blinding of the screen. Why? It's because the product is starting to cover the wire of the mesh. And after a while, you see that it's completely blinded and no product can go through. So over the production time, you will start from 100%. And after a while, if you don't do anything, no product can go through. And that's a problem. At Sweco, we have different solutions that I will present you. So some, what I call self-cleaning accessories. The first one is the self-cleaning kit. So it's some sliders, rings you have below your screen that will hit the mesh from below and deblind it. You have the self-cleaning kit integrated in the screen. It's the self-cleaning screen. It's a sandwich screen. We also have bolt trays, power wheels, spray system, and ultrasonic systems. I will go through them quickly. So for the self-cleaning kits, as I told you, you have the screen, you have a perforated plate, and on top of the perforated plate, you have some rings, we call it sliders, that will hit the screen from below and remove what we can have, the near-sized particles blocking the passage. The other integrated solution is the sandwich screen. So where you have everything, you have one screen with the sandwich screen. Sandwich screen with the ring. You have the sliders. You have the top mesh that we use, and at the bottom you have the support cloth. In general, sandwich screens are working a bit better and with less noise because we have a smaller gap between the sliders and the screen. And from a maintenance point of view, it's easier, to slide in a screen directly to the machine instead of putting a perforated plate, install all the small rings on top of the screen. From a maintenance point of view, it's less time consuming and it will be faster to change the screen. Another solution is the ball tray. It's when the product is really heavy, when you want to transmit more energy to the product to move it. We will use balls. In general, as I said, for heavier materials, the thing is that the impact of the balls are smaller, so will have to use it with bigger apertures, not with small one, otherwise you can break the screen. Another type of solution is the power. We have different versions: necklace, wiper, wheel. So necklace is to keep the product inside the screen. The power wiper is to break the lumps, the agglomerates of powder, and the power wheel, it's a combination of both. It's usually used with dry powder applications, but it can work with wet applications as well. We have spray systems. So for rectangular machines, usually we consider traveling sprays. It will travel over the screen. For round separators, we have rotary sprays, and we also have a fixed spray system for round and rectangular separators. So it can be considered as a cleaning in place, CIP system. Ultrasonic system. Why would we consider that? It's, in fact, with a trisonic system, you will create a secondary motion to deblind the system. So an ultrasonic is usually composed of a generator, a converter, and the resonator that will transmit the vibrations to the powder. It's usually used for application with really light powders, and we use it sometimes by pulses to clean the screen at a certain frequency. So now we will go to the live demonstration. Here we wanted to show you some example of deblinding solutions. So first we had the power wheel. So as I told you, it's a combination of a power necklace and a power wiper. So this accessory will keep the powder in the center. So the product will stay longer on the screen to have a better sieving, and it will break the lumps, the agglomerates of powder you can have on the screen. That's one solution we have. Another solution is the ultrasonic system. So we have an example of that system here. So we just flipped it over to show you the system. Normally it should be placed the other way around. We have here the resonator that will transmit the secondary motion to the screen. We have here the connection to the converter and to the generator of the ultrasonic system, and that's the system we have. Up. And now we'll show you the principle of the self-cleaning kit. So what's a self-cleaning kit? It's the sliders, rings we have below the screen that will hit the screen from the bottom, and they will hit the screen on top, and to remove all the particles that can be stuck on the screen. So we'll start the machine to show you the motion. So you see, in fact, the sliders, we have different movements. You have a rotary motion from the sliders going clockwise, and you also have the vertical vibration of the sliders hitting the screen. So the whole screen will be clean of possible particles stuck in the screen. So that's for the deblinding solutions. We'll go now to the weight settings of our motor. So I will first explain what we have currently and the weight we have on our latest generation of separators, the HX version with the ProGlide linear weight system. So this is what we call the power wheel that is used on our US model with the top weight and the bottom weight. On the top, that will give you the horizontal force. The bottom weights will be used to create the vertical force. You have on each wheel wings. You can understand that if you put the wings closer to each other, you have more centrifugal force. So we have more force. If you put them apart, so they will have less force. The top weight will be the reference, so always 0 degree, and what we call the lead angle will be the angle we have the bottom wheel. So for the top weight, we will put 6 slots. So I will start with the left wing. So 6 slots, it's there. I will put my wing 6 slots up, and I locked it at the 6th slot. I will do the same with the left wing. I will put it also 6 slot and lock it. So we should have the same number of slots on each side. So that would be, you have it will be balanced. Now, if we look at the bottom weight, it's now set at 60 degrees. We'll put it at 30 degrees with six slots on each side. So first we will check where are the 30 degrees. So 30 degrees, it's there. And you will put 6 slots on each side. So 6 waves, we would say. 1, 2, 3, 4, 5, 6. So my weight should be placed here. I will lock it. 30 degrees, I will do the same on the other side. 1, 2, 3, 4, 5, 6. Wait, sorry. 1, 2, 3, 4, 5, 6. Up. And I will put my weight there. I will lock it. And you see in the middle, you have the lead angle that will create the motion pattern. And on each side, you have the weights. So the lead angle will give the motion pattern. If you consider 0 degrees here, the product will go directly to the outside. If you increase the lead angle, you will create a spiral on top of the screen to have more, the product will stay more on the screen and you have a better sieving. We'll now move to our latest generation of machines, the HX series, with a different type of weight setting, weight systems. And that's what we call the ProGlide. So that's the linear system. It's easier to use, more user friendly. So here, instead of having 2 wings, you have a linear system. You have, so that's the top weight. You cannot change the angle, of course. But if you want to increase the horizontal force, you just have to slide it and to lock the weight. And with that, you see the weights you have more centrifugal force because it's far from the center. If you want to decrease the force, just have to adjust it and put it closer to the center. That's for the top weight. If you look at the bottom wheel, you see we have exactly the same weight system as for the other system. You see the angle, 0 degree, you have 30 degree here, you have 60 degrees. So now I will show you how to do it, how to change the weight settings on HX, an HX machine with a ProGlide linear weight system. You just, as I told you, lift, push first the weight, lift it, and you can change the angle. We put the angle as 30 degrees here, and you can lock it. We can also change the force you have on the bottom wheel that will give you the, as I told you, the vertical force by just unlocking the weight and moving it to the outside here. And if you want to decrease the force, you just have to unlock it once again and push it more to the center. That's how you can easily set the weight. So that's for the HX series we have. That's our latest generation with the ProGlide